Okay, let's get it started. Can you guys hear me? All right. Okay, let's get it started. Hello everyone, I'm Lee Hao from Shining 3D. I'm the application engineer, and welcome to our Shining 3D webinar. Today we're going to talking about this unit, Transcan C. I know some of you already have your hands on it, but some of you still looking for kind of demo or whatever. And this is what we're gonna do today is to talking about the setup and calibration about this unit, as well as some of the scanning and some of the Q&A time. All right. So, okay, let's get it started. The first part we're going to talk about is the scanning setup. Okay. And here you have the box content. You can find this information on the quick guide, which came from together with the scanner. After you open the box, we'll be able to see scanner head, power cables, power adapters. There will be two because one is for the scanner, one is for the turntable. And you have the connection cables. You have two calibration board because we have two range for this scanner, 150 and 300. Then we have the calibration board bracket, which is the holder for the calibration board. And we have the calibration pad, which is this one. It tells you where you can put the calibration board positions to help you go through the calibration. And we have, of course, we have markers in two sizes. The larger one is for the 300 millimeter range, and the smaller one is for 150 range. And of course, we have this turntable here, and we have this tripods to set up the scanner on. This one actually is a normal camera tripod. So if you have your own camera tripods, you can use it as well. So to set up the scanner on the tripods, it's quite the same as how you set up your camera on the tripods. All right. So as I said, it's a normal camera tripods. So it use one screws to put the scanner on. This one, it's actually normal screws, same screws for all the cameras. So you just first put the adapter onto the bottom of the scanner head, screw it in, and you just put it back onto the tripods. Okay, and tight it. Make sure it don't fail. And that's it. And next is connected to the computer. You can see the computer requirements on the screen. Okay, it's kind of normal. It's kind of the same as other ion scanners. We recommend you using the latest gaming laptop. It always works. Like what we're using here today is Dell G17, I think. Okay, and one important thing is on the computer you at least need to have two USB ports, and one of it should be USB 3.0 port, which is for a scanner. This one only connect to the 3.0 port, and the other one will be either 3.0 or 2.0, both okay, which is for the turntable. And we do see some of the offline issues happens. We just update the software to 1.4 to 0.2.1 version, and this version give you a firmware update which is supposed to solve most of the offline cases. However, we do see one case that even with the newest firmware, the scanners still have offline issue. And the ultimate solution, this is probably because the computer USB port is not good enough. Some of the computer USB port don't have good power support. So a way to do it is using USB 3.0 hub to connect through to your computer. This one always, I would say it's kind of like an ultimate solution. So it definitely will save the problem if you have offline issue. And of course, the scanner works. Okay, so let's go to the next. Connect to the computer. For the scanner, we usually only use the 2-port here. One is for the power. One is for the 3.0 cable connection. This goes to the computer. And for the turntable, it's the same. There are 2 ports, one for the power, one for the USB cable connection. You can also find this on the quick guide. Make sure you go through them. Okay, and after the scanner is connected, you will be able to find a device in the device managers. This one, I recommend you to check if there's something not going well, for like if the camera is not working or projector is not working. Please check the device manager and see if the hardware can be found in the device manager. If the scanner connection is good, you will be able to see one human interface device, which is the projector. Here you can see. And also you'll be able to see 2 USB 3 camera, like this, USB 3 vision cameras. These are the camera of the scanners, okay? Usually the camera driver will be installed with the scanner software together, but sometimes if the computer security setting is high or the driver is corrupted, you can manually install it. You can find it under the scan software folder, okay? Now, that's all for the talking, and we can start for the device adjustment. First, I want to talk about is when to do the device adjustment. Every time you switch the scanner range, you need to walk through the full scanner adjustment and calibration process. And the first step for this would be choosing the range you want to use. 100 millimeter, 150 millimeter range. This is going to have 2 range, and a small one and a larger one. The small one is 150 millimeter range, which give you a better detail. And 300 millimeter give you a longer focus distance, a larger scanning range, and help you to scan a larger object more easily. But the detail will be worse than 150 range, of course. Okay, let me switch to screen sharing. Here you can see my software interface. We'll go through the device adjustment with you. Okay, we will do the 300 first, then 150 millimeter. So here we choose 300 millimeter first. Click on the next. Okay, here comes the most important part, is to set up the scanner and the calibration board positions. All right. For this, we first will be set up this calibration board. What we're going to use is the calibration board stand. This one you can see here, we have a mark 150 and 300. It all goes through the same slots. So you just put it to these positions and put it on the calibration board pad. You notice that we have a 300 side and 150 side. Since we're doing 300, we will use this side first. For the device setup, you're gonna put the calibration board stand on the blue line. It's 1, 2, 3, 4 position here like this, and just put the larger 300 millimeter range calibration board onto it, like this. This is how you set up the calibration board. Note that there's an angle. It's around 70-degree angle between the calibration board and the table surface. Okay, and then the calibration board side is okay. Next, we'll be setting up the scanner part. There are two things important for this. One is the distance between these two, and the other is the angle of the scanner. Okay, for the angle of the scanner, you have to make sure that it looks like 90 degrees to the calibration board. Raise it up a little bit. And for adjusting the scanning range, we will use the projected area. As you can see, that the closer I move, the closer the scanner is, the smaller the projector area will be. So the project area is connected with the scanner distance. So what we want is actually on the screen, on the bottom right side, you can see the calibration board and the projected areas. And what we want is the project area should be covered these 2 points here. You see we have 2 points with pattern around it, and the projected area should be covering both. Should be covering both points here. And also the cross needs to go through the center point. Okay, and another way to check the angle is you can put your fingers next to the calibration board, and if you see the top and right have a similar distance, it means the scanner angle is kind of okay. All right, so this is how you set up the device and the calibration board. This is actually the most important step of the whole calibration, whole scanner setup. If the scanner angle is not right or the distance is not right, the 100% calibration will not be able to pass. Okay, so after it's set up, we will do the next is adjusting the scanner range. For this, from this, you will need to take off the camera cover. And you see there's one large screw next to the camera, and we need to untie it in order to move the whole camera unit. There will be, once it's loose, you will see this screw popped up, and then you can slide the camera. We are doing the 300 millimeter, so we need to move the camera to the 300 millimeter range and put it back and lock it. And make sure both cameras are on the 300 level, 300 range. Okay. And next, we're going to focus the projector. So you see there is a ring outside the projector. There's how you turn in it, is how you adjust the projector focus. A good good focus is to make sure the projected pattern, the cross is sharp and clear. Like this. Should be good. Okay. And next step, we will be adjusting the camera angle. You will be able to find a hex key under the camera. There actually will be two, one small, one large, like this one. And we will be using the smaller one. So put the larger one back. Okay. And you see there's one screw back of the camera here. And you can just loose it. And you'll be able to see the camera turning on the software interface. What we want to do is we want to match the red cross on the camera side with the projected leg cross. Now, once it's aligned, you need to tighten the camera. And do the same thing for the other camera. Make sure both cross match. Okay, then tighten it. And you can put it back. Oh, just out. And then, okay, sure. And the next step will be changing the aperture. For this, we usually actually only check if the aperture is at the good place. We recommend the aperture to be at the 5.6, which is the point between 4 and 8. And both for 150 and 300 millimeter range should be on the 5.6. So it should be on the points between the 4 and 8. So you don't really need to change it, but I recommend you double check if it's at the right place. And the final one will be adjusting the camera focus. For this, I recommend you to put a sheet of paper with letters on it like this. We are using the calibration certification. So you see we have the screws on the camera. You just loose it, and you can double click on the camera window. And when you're turning the focus ring, you see the focus changing. And what you want is a sharp view. And you want to do the same thing for the other camera. And you can actually click and drag the camera view, go to a place where you see a lot of letters. And you can turn it forward and backward until you see the place where the focus is good. Okay, and that's it for the setup. And in this window, I will be checking the turntable connection. And you see it's connected. It means it's past checking. After it, we'll be entering the calibration. Shit. Sorry for the noise. All right. Here we are entering the calibration window, and you will be able to see two things on the software interface. On the left, it will be the instruction for the calibration, and on the right, you will be able to see both camera feeds. Okay, so for the calibration, both for 300 and 150, we will go through 10 steps. So you will be taking 10 shots of pictures for the calibration. And you can also see the marks on the calibration pad labeled with number. It indicates the positions for all the 10 shots. Okay. And when you're doing these shots, you have to check two things. One is how the calibration board should be put. For example, for step number one, you need to have you see on the screen there are green dots marked. There's actually 4 pattern dots, 5 pattern dots should be at the bottom. So like this on the bottom. This is the first thing, the calibration board position. Then the other one is the camera brightness. I usually go from the lowest brightness setting, and I went up. You need to stop at the first step where you see red on the calibration board. This means you're at a good brightness. And then you can click on the capture, or you can hit the space bar. Usually if the distance is not changed, you don't need to change the brightness again. So for step 2, you just turn it 90 degrees. And step 3, also make sure the center line aligns. Step 4. And now for the step 5, you need to change the calibration board position. And also, you have to turn it 90 degrees again to put the 5 pattern points on the bottom. And now you can move it. You see there is one yellow line marked with number 5. This is where the calibration board seats should be pointing at. And here is a small box here. It should align with the center mark of the calibration board. Calibration stance. Here we go, step 5. And same thing for 6. You have to move to the line first, then go to match the box with the center mark. Make sure you don't move the calibration pad during the calibration, otherwise the position will be in a mess. Number 7 is pointing the other direction. And number 8. You'll see that each line is marked, you will be able to see a number marked. Okay, step 9 and step 10 might be the most tricky ones. For step 9, I recommend you to double check the camera view. See if you still got the redness on the calibration board. If it yes, then you can do the shots. And if it didn't have the red on the calibration board because we moved it far away, you might need to bring up the brightness one more step. And now we go to step 10. One important thing for step 10 is that it's actually important for each step is you have to make sure there are 5 marked points here, pattern points in the middle, and these 5 should be able to see on the screen by the camera, and especially for step 10, because when you're moving closer, you see the projected area is moving up, and make sure the bottom 2 marked points can be seen. If it cannot be seen, you can actually move the calibration board a little bit back until the camera can see both points. Here the calibration for the camera is success. Next thing will be the white balance. And for this, we'll be using the back side of the calibration board. Or if it's not so clear, not so white, you can use the sheet of white paper. Make sure you move it back to the 1, 2, 3, 4 lines here. And you also need to adjust the camera brightness. You don't really want the full red area for the calibration board. You only need to adjust it until you see a red cross like this. And you click on white balance. This step is actually telling the scanner what is white color. It's very important if you want to get a good color scan. And after it, you can click on complete. And that's how you set up and calibrate 300 range. And next, we will go through the 150 range. Actually, the most part are kind of the same. Same idea, same important thing you want to check. One different thing is, of course, you start from the at the front. At the start, you need to select 150 millimeter range. Here, choose 150 millimeter. Okay. Let's put the calibration board back on. No, you have to change the side of the calibration board pad because for 150 we will be using the other side. Make sure you don't do it like this. You don't move it back. You should make sure it's facing the scanner. This side facing scanner. And the board should be at the same angle, 70 degree. Put the board on. Like this. Same thing, you put it at the blue line, the 1, 2, 3, 4 line. And the next thing will be adjusting the scanner angle and positions. The angle should be the same, so we don't need to adjust angle again, but we need to adjust the distance and the height. We will be also using the scanner range to check the distance. But for this time, we actually, for the 300 millimeter, we're looking at the top and bottom side of the projected area. But for the 300 we are actually looking at the left and right side. And a good range should be like this. So the left and the right side of the project area should align with the inner side of the rubber seal on the calibration board. Like this. And of course, the cross should go through the center point. And you can also see this on the screen. Let's go to the next. This one is also the most important part. If you don't have these two sides aligned perfectly with the calibration board and the rubber side, you may face calibration fail. Okay, so next thing we will be loosening the screws here. Remember I said you need to lose the screw until you see it popped up by the spring. And you just slide the rail, and when it's reached 150, you push down the screws and lock it. Do the same thing for the other side. And now, let's do the projector. Since we changed the distance, you need to focus the projector again. Make sure it's clear and sharp. You might need to turn it backward and forward until you find the sweet point. And also camera angle. We're using the same hex key. And it's a screw. My finger is too large. Okay, here we go. And also you need to match the cross again. Aperture, as I said, you don't need to change. And finally, the focus. Let's bring up the certification again. It might be too bright. You can also look at the edge of the points. And the right camera, remember you can drag and move the side to where you want. Tight it. Okay. And let's go to the calibration. By the way, you can put back the camera cover after the setup. This helps to protect the camera from dust or other things. And the calibration process is quite the same. You have to go find the good brightness, And usually for 300 millimeter, it's either the first or the second one. And make sure the pattern is in a good direction. You can check on the screen and see if both pattern match on the left and right camera. The 10 steps will be the similar, so you just turn it 90 degrees for number 2. Now number 5, you'll be able to find the line marked with 5. Align with it. And 6. Also, the center mark should be aligned with the box here. Seven. And 8. The most tricky parts will also be step 9 and step 10. Like I said, you see, for step 9, now you need to bring up the brightness 1 step up. And for 10, make sure you put it back. Here, everything success. And you need to do the white balance again because since the distance changed, the white balance data might change also. And change the brightness. Okay, and complete. All right, so that's how you can do the setup and calibration. Let's sum up. So for the setup, it's actually the most important step. You have to make sure the scanner is at the good distance and good range. I don't recommend you to use rulers to make sure where the scanner is, because if the angle is different, it will give you different readouts. I still recommend you to first check the angle, make sure it's around 90 degrees. You don't have to be perfect 90 degrees. And I prefer to have the scanner more leveled instead of inclined, looking down. So the other thing is the distance, and I recommend you to check the distance based on the scanner projected area. like I said before, for 150, it should be aligned with the inner side of the rubber seal, left and right. And for the 300 range, you should look at the top and bottom side, and both should cover these two pattern points. So the area should cover both of the points here. And also, when you're doing the calibration, make sure the pattern is at the right position, and make sure the brightness is good enough. You need a little bit red on the calibration board. All right. Okay. Let's go to the next part. So some scan tips. Before the webinar, we sent out the invitation and asked some questions about what kind of things you guys want to learn about scanning. And I see most of the people were talking about scan thin wall object or black object. Actually, for Transcan C, it's pretty easy to scan the black object. For example, we have a remote control here for the TV. It's pure black plastic. This kind of black surface is easy for scanning. Let's go to the screen sharing. For the scanning, you have to make sure the scanner is at a good distance. The way to do it is to make sure the projected cross is matched with the red cross on the camera. You can check on the software here. Then, if you want to scan dark object or black object, you have to move the brightness at the high level. And you see it's able to capture black surface with no problem. So I would say if you want to scan black object, Transcan C don't have any problem to do it. And the other thing people are asking about is to scan thin wall object, for example, things like this. Usually for fixed scan, it's hard to align both sides. And when you scan thin wall object, if the object is small, like this one, you can actually stand it on the turntable first in an upscale way. Make sure it do not wobble. And let's check the scan width turntable. Let me delete the data first. And you need to adjust the brightness, of course. Okay. And you can choose the feature alignment, or since we put the markers on the table, you can also use the marker alignment. I will do feature alignment because I want to show you guys the way to use this skip turntable location verification. You see that if you turn this switch on, if you're using this the first time, if there are turntable location already stored in the software, it will try to align the data based on the former turntable location data. But since we already changed the location, we cannot use the old data. So if you use the turntable for the first time, I recommend to turn it off. You see the data is misaligned. This is because it skips the turntable location verification. So if you're using the turntable for the first time, please turn it off. Here, like this. And you see the software will try to, it says verifying. It's actually taking 4 shots, and each shot will be like 2-degree turn, like this. And the software will try to align the 4 shots together to calculate the position of the turntable. And for the other scans, it will use the turntable location to align the data. Now it's doing the verifying by taking 4 shots. And now it's actually aligning the data based on the turntable positions. And if you scan the thin wall object at the stand-up position like this, the software, the scanner will be able to align, by the turntable, align both sides of the thin wall object together. And here the full round is down. Let it finish. Okay. And there's a way to delete the data you don't need. Is you can first select part of area of the data you want, and here click on Connect Domain. It will try to select everything, all the data that connected with the area that you selected. Now you can click on Invert and delete data. This helps you to delete some of the environment data. Okay. So after the first run is done and the turntable location is verified, you can keep scanning by turning the skip turntable location verify on. And you see now it will not verify the data. And since the turntable position was not changed, it can align the data without problem. Oh, we just tilted the scanner. That's why there are still misalignments. Just don't forget, if you change either the scanner angle or the turntable location, you have to turn on again. You have to do the turntable location verify again. I just forget that I just tilted the scanner a little bit. Anyway, the way for you to scan thin wall object, if it's small, I recommend you to scan both sides together in upscale positions. Then you can scan each side one by one. The software will be able to align them together. If you want to see me scanning the black remote, we can do it later after this turn. And we will share the webinar. I think we already recorded the webinar, so we will post the record online. I think probably on YouTube, and we will send out the link so you guys can check it on the Shiny 3D YouTube channel. Just remember that anytime you see, if you're using feature alignment with the turntable, anytime you see misalignment, please make sure the skip turntable location verify is turned off. and the back side is down, and you can scan the front side the same way. And another thing is if you were to scan a larger single object, for example, if you want to scan something like this, maybe even larger than this one, you cannot use the turntable to do the trick to align the both sides. In this way, you probably need something else to help alignment. For example, you can get something like this and put the markers onto it, and you can set it aside with the single object. Make sure it stands still and have this marker object stand aside it, and you can scan them together from this corner and to align the both side of the corner together. And after that, you can scan the both sides one by one, and the both sides data can be aligned with this. And you can delete the object later. Or another way is you can also put markers on the table or on the ground, which also can help you to align the data. Like, for example, we have the markers on the turntable. So if you put it like this, you can take shots from this side. It will capture the marker here. Then you can move the scanner to go the full round to the back side. In this way, it will help you align the both sides together. All right, let's scan the remote. So should I take a look? Let me delete the data. Okay, for this time, for real, we didn't change the position of the turntable, so you can turn this on. Oh, wait a minute. I didn't get a good brightness. Let's bring up the brightness. And you might need to scan it in upward position to align the both sides. The computer I use for the presentation is not a very strong one, so it might lag a little bit. You cannot create the cutting plane if there's no data at all. And since for each turn the remote will be at a different position, so I don't recommend you to use cutting plane for this object. But I think for other case, if you use you can also use the. I can show you how to use the cutting plane to clear out the data, but that's actually not the way we want you to use the cutting plane. You see, since I turn it up a little bit, the turntable plane will be at a different position. So if you use the cutting plane, it will be cutting the data beneath it instead of here. And let's align the two sides together. Again, for the verification, as I said before, it's actually taking 4 shots. Each of them were like 2-degree difference. And based on that, it will try to align the 4 shots together to calculate the turntable location. And since I just moved the scanner, we have to do the verification again to get a good alignment. And scanning this remote in this position is to align the front side and back side together. Yeah, the software is a little bit slower than the scanning process. This is usually because for 150 millimeter range, the data size for each scan is really large. So the points that you collect for each shot is really a lot. And to process the data, like I said, the computer I use is like only 16 gigabits memory, and it's not using the best graphic card you can get, so it's still a little bit slow. So this term will help you to align the front and back together. And you see the software will align both runs together based on feature. So it's currently aligned. Okay. You can do global optimization again. This one will help you to check the alignment again to make a perfect alignment. And now you can do the back side of it. For the backside, there's actually not too much, how to say, features. So you may need to we may need to do manual alignment. Let's have a try first. While we're waiting, is there any other questions you guys have about the scanner? You can type and send it, and we can try to reply. Let me try a different angle. Fix it. The object actually wobbles. Dark and bronze and black and wood objects. Yes. Okay. For dark object, not all the models working well with dark object. For Transcan C, since the projector is kind of strong, the projector light is bright enough. You can scan dark object easily. But for other models, for example, if you were using iScan Pro 2X or the old Pro 2X Plus, the scanner or like the Edge or Edge X, the light is not strong enough, so it's really hard for scanning dark objects. And if you are using other model, I recommend you to spray the object with like baby powder or other things to make it wider. It also gives you a better data because for dark object, the scan data is not so good. What's the other question? Any suggestion to provide appropriate training to client? When you were doing training for the customer for Transcan C, like I said, and like what we did today, I think the most important part is for the setup and alignment. We will send out this video, this webinar video recording, and we also have a calibration video online. You can let the customer to check it. But like what we did today, the most important process is teach them how to set up the scanner, what the scanner distance will be, and how to pass the calibration easily. If you set up a scanner at the right position, it's actually not that hard to pass the calibration. And that's what I think should be tracked for the training. And for scanning, it's actually not that hard. It's more like when you were scanning with industrial pack for the handheld scanner, or like those turntable scanner. Not too much difference. The only difference is the scan distance and focus distance. And also this unit has a brighter projector, so you can probably scan dark object or a little bit reflective object. I guess the backside is not able to. Okay. It's probably the backside of this remote is do not have enough data to help doing alignment, to help locate the turntable. Well, there's a way to do it. Is to, like I said, we can use one term to, actually it's a good example. So for things like this, where it's hard to do the turntable location verification in a good way, because you see the full surface is at the same shape, so it might easily align at the wrong place. For this kind of things, I recommend you to scan something with unique shape first, to have the turntable location verified. Then delete that round and scan again without turntable location verification. And after that, you should be able to get this round aligned perfectly without verification. Because the only thing that's not doing well is the verification. Or actually, for this scan we are doing now, I feel like single shots should be good enough, because the shape is pretty simple. Let's see if we can manually align it with single shots. Align right. It actually aligns good. Okay. Let's do the other side. To apply a reference on a remote itself, yes, there's actually a lot of different ways to do it. You can put Play-Doh on top of the remote and help to get more reference to help doing alignment. And you can delete the reference later. That's another way to do it. There's always not only one solution. It's actually misalignment. Let's see if we can manually align it. You can use the Bluetooth mark. One here. And you can use the center of this. Maybe this side. Just trying to get the side of the remote. Any other questions you want to ask? I actually don't use LinkedIn, but the profile I set up is like years ago when I was still studying. If you have questions, I recommend you to like email me. I can give you my working email address. It's my email address, and feel free to email me if you have questions. Technically, of course, if you want to ask about the price, I recommend you to send email to sales@shiny3d.com. If you want not to scan the turntable, actually, there's not much way to do it. Because for Transcan C, it's also easy to scan black objects. So even if you put for example, the bag for the calibration board onto it, it can still capture. This is the downside for the scanner can capture a lot of different surface is that it's hard for you to avoid capture data. I'll say probably the easiest way is still going to be deleting the data manually. Using the cutting plane can help you to avoid scan the turntable. However, we can only set up the cutting plane after you scan some data. And if you turn the object, for example, if I turn it 90 degree on the turntable, you have to reset the cutting plane again. So it's for Transcan C, it's not the turntable itself is not able to automatically recognized by the scanner because we don't have we don't calibrate the turntable together with the scanner like the desktop scanner do. I tried the single shots for the side, but it's actually not picking up much data. And if I only get the side only, it's probably not gonna give me a good result. And you'll see the global optimization helps a lot for thin wall object like this because it's hard to get the alignment right. And you get the idea. I think the rest will be just scanned upside down again to capture these two sides on the bottom, and you will do watertight and give you a good readout. Any other questions? I think I already reached the time. A reflective object, if it's something like the calibration board plate, it's okay. So the metal piece is okay. Mirror, of course not. If you want to see the scan texture data, we actually did some. Let me see if I can find a project. And if you want the color data, you can ask. So this one is something I scanned yesterday, and the color is pretty right. If the color is not good enough, I recommend you to do white balance again, and you should keep the uh, room, the scan room pretty bright, or at least you should have a good white light in the room. Otherwise, the texture may not be so good. So for texture scan, the most important part is doing the white balance right. And there are two points. First is the room. We recommend you to have a room with white light instead of the yellow light from the light bulb. And the other thing is, make sure when you're doing the white balance, make sure the brightness is good enough. So as I mentioned before, you should be at the place where you see the red cross instead of the red for the full calibration board. And that's it. And thank you guys. And thanks for watching.